up to the ding ding dong day.
Hello everybody, hope you're well. I've been watching some Unreal PCG videos from Freetime Coder, who's making some awesome creations. You should really check them out if you're into procedural stuff. In this video, I wanted to try something with PCGs myself based on what I learned from Freetime Coder. So first I shall enable the plugin and save my empty map. So far, all PCG tutorials have shown how we can create and generate random placements of points, which is really awesome. But in this video, I wanted to explore the possibility of creating something mathematical in terms of the patterns. That way we can get the randomness, but also something that follows some mathematical rules. So there's like a method to the madness. The mass of choice is Phyllotaxis for this video. Phyllotaxis is a mathematical pattern closely related to the golden ratio and the Fibonacci angle, and is found quite a bit in nature, from aloe vera, pine cones, and even seashells. So it's a very botanical pattern. I asked ChatGPT to give me a Phyllotaxis algorithm, which after cutting the clutter out came to look like this. It is a fairly straightforward algorithm, as you can see. The main part is in the for loop, where we have to calculate some logic to move the points around based on those global variables, and that we'll come to in a moment. So I'll let you absorb that for a minute, and I'll dive into our PCG graph. So I'll name my graph Phyllotaxis underscore PCG. Double click to open it. Also place it in the scene. And so we just connect the landscape to, well, the sampler, surface sampler. There you are. Okay, so we have the points there. Let's click debug, and let's just get a static mesh in place, like a tree or something, just to visualize it better. So the way you do that, just get a static mesh spawner. Let's see if I can spell it right. Yeah, there it is. And just add a mesh entry, and from here I need to select the tree. Just go with anything in the last one. Preparing shaders, I think. So let's debug, no, remove debugger. Nothing. That's weird. Okay, actually there's no entries there. Not sure what happened, but again, create the entry and then select the static mesh. That should bring the trees. Okay, so now we want to use these trees and arrange them in the Phyllotaxis pattern that we saw earlier. So the way we do this is by using a custom node. So that would be a blueprint. So blueprint class, and from here we get the PCG element. Yeah, PCG blueprint element. And if you saw the Freetime Coder video, you can see this is a bit of a complicated kind of blueprint. There's quite a few boilerplates and stuff, and as with Freetime Coder, there's a lot of stuff that I don't know. I'm just following along and just copying those things that he's done, but it's the logic part that will get really interesting. So first, execute with context. So I think it's a way to tell Unreal that you want to execute in this context, this particular PCG context. A lot of it is likely to change once this goes full version from preview. So yeah, take it all with a grain of salt. And okay, so get points. So I got the inputs from the context, and I need to, again, I'm just following along free time coder. I've got it up on a second screen just for this part. The next thing I need is break PCG tag data. Okay, and then cast PCG. Yeah, that's right. So we just need to convert those points into a data that we can manipulate. So we need to get it into an array or a collection, which we can use the basic blueprint principles to manipulate. Okay, so now we have the point data to context, and now we can go to create a loop on points, because that's where we will define the logic. That loop, the for loop that we saw in the algorithm, it goes in there. And then we also need to connect these executions like with any blueprints. I'm assuming most of you have some blueprint knowledge. Now if you have no knowledge, this is not a tutorial that will help you at all. So for conversions, so let's take this output and search for make, I think it's make PCG tag data. Yeah, that's it. And then we're going to have to bring it back to what it was before, after the points have been changed, and then send those points back to the graph. Essentially, think of it like we have these points and we want to be just converting it into a language that is understood by the loop and the other programming nodes in Blueprint. And then once we have our output, we're converting it back to the source types. And a lot of this will get much clearer when we get the documentation for what these nodes are and what they're trying to do. And oops, actually, the context should be connected. I also just noticed, why am I using multi-loop on points? Is that gonna work? I think I'm meant to lose just the loop on points, but let's first drag this into the actual graph just to demonstrate that we have a custom node and this is what we want to do. We want to remove that, and basically the sampler goes into the custom node, which is generate Phyllotaxis, and from there we go to the static mesh spawner. So first we change the points and arrange them in the way we want, and then we replace those points with our static mesh. So yeah, first of all, let's change this to loop on points. Now just delete it. Loop on points. Yeah, that's the one I intended to bring up. So again, note that, and this one, execution order, important. And again connect this one up, and then the execution goes to the output. Now we're ready to dive into the for loop, or loop on points as we call it. So for that we need to find it up here. Now we're in the loop body, and this is where all of those variables and logic that we saw in the algorithm come into play. So I'm gonna have to create a few variables first. Let's call it fib underscore angle, and this will be a float. We're gonna need a scaling factor, so let's create another float, scaling underscore factor. What else are we gonna need? Angle. We have to calculate the angle for each of the points, and also x for x position, and then y, and also we need a position vector. Let's just create it. If we don't need it, we don't need it. But I'm thinking we might need a 2D vector to pass x and y values. Oh, actually, we don't need it. I'll just ignore it. Let's keep going. I'm just glancing at my algorithm and see what else we're gonna need. We need a. Well, let's just begin the algorithm and we'll create more variables on the fly. We need to. So, in data has a get points node, and this will we need to find the index, the current index of the point, right? So that can be done using find, and we also need to plug in the endpoints into the input of find. So we're trying to find the index of the points. That's kind of what we're trying to say here. Right, so what we're doing with the index, so let's connect up. So we have to calculate the angle by first of all getting the Fibonacci angle, which we should give a default value. Let's compile and give it 137.5 as per the algorithm, and we need to multiply with the index. So each point gets a different angle value, and we set it here. And the next thing is, so x and y go through a different math. So x goes through cos degrees, so cos of angle is what we want for x direction, and for y we need the sine of it. I don't think it matters which way you want to go. Y could be x, x could be y, but it's just those two axes. They need to have cos and sine, so they're like opposites. So sine of degrees, and now we need to do a bit more math. So bring my x. So to get my x, I need to again multiply the cos of the angle with radius. Oh, that's right, we didn't create a variable for radius, once we get the radius, that goes into the other pin of the multiply, and then we have our x value. So radius, and it's not a vector 2D, so let's change that to bring that in, and we want to set it again by, well, this will be our next execution. I want to get the square root as per the algorithm. So let's just square, yeah, that's it, square root function. Yeah, it wouldn't accept it before because it need to be converted to an integer 32 first. So that was the way to do it. So now we have the square root of index. We multiply this with the, where's the scaling factor? There you are. Get it. We don't need to set it because this is a global variable. This is something we'll pass externally, and then connect it to radius, adjust the nose, I have a very creaky chair. If you're hearing any noise in the background, it's my chair. And to set the members, so set members in yeah, that's it, PCG point. So connect them up, and well, I need to expose more of the parameters, but I think, yeah, let's connect it up first and structure. Yeah, that's it. It's just the points. And now in the properties, let's connect the output first. In the properties, we should have a few options, and all we want to do is change the transforms in the x and y positions. We're not interested in any other parameters, so that's what I'll try to expose. We are now ready to plug in our x and y values into transform x and transform y. So multiply it with the radius that we calculated, and that will be the final x position. And we need to do the same with y. So first, get another multiply, plug the radius, this goes into x, trying to find the best way to arrange these nodes. I'm not a huge fan of the way blueprints are. It's just maybe I'm not that used to it. When it comes to nodes, it's just the Houdini that I'm really good with, but with everything else I'm still figuring stuff out. Okay, so y goes through similar treatment. So we set the y, and then get multiply it with radius again. logic done, if we've done it correctly, then we should see a Phyllotaxis pattern to our trees. Let's compile. Okay, they're all kind of gathered in one place, and that could be something to do with the scaling factor. So since it's a global variable, you should see it in the properties here. So it's set to 1 currently. Let's try 10. Okay, move the window around, something happened, and disable the points. Just want to see the trees. Okay, zoom back. Looking pretty cool. Alright, that does resemble the Phyllotaxis pattern, as you can see. Very similar to the images I showed you earlier. So let's say change the angle now. 125 gives us snowflake-like pattern, and this is the power of using maths. And I really wanted to demonstrate, because it's fine and dandy to like scatter a bunch of rocks all around randomly, but what if you wanted to stick to a pattern and something that logically moves? Look at this, for example. I mean, you're just changing the angle and getting a completely different arrangement, and yet it's not completely different. There's logic to this magic, and this opens up so many like level design opportunities. Of course, this is what procedural generation has always meant in terms of game design and film design, but PCG basically lets an artist to do this, and if you can do a bit of code and maths, you know, it's so much quicker. So I really can't wait for this to come out of preview and have a strong documentation available for us, so doing such things becomes so much more easier. So that's about it, and I can't wait to see what others come up with, because there's a lot to explore. This is just scratching the surface. As and when I learn more about PCGs, I will try and create a mini project like this one and come back and put it in a film or a game context and do another video in the future. So I hope you enjoyed this video. Do like, subscribe, and add a comment, and let me know if you would like to see more of Unreal PCG tutorials in the future. Thank you very much.